Before we get started on this goal, I would like you to stop the video and take this little quiz just as review. Okay, we're back. Let's go ahead and go through the answers. So number 1, which of the following are ions? An ion is an atom with a charge. And so we have here positive and negative charges, and all of those would be ions. So the only thing that is not an ion is this one, but it's all of them except for that one. Number 2, what is a cation? A cation is a positive ion. And how I remember this is in the word cation, there's a T, and so it's like a little plus sign. So the ones that are cations are A and B. Those are the positive ions. Number 3, what is an anion? An anion is a negative ion, and there's 2 of those. So C and E. And again, there are negative ions, and I remember that because in the word anion, there's 2 N's. So that stands for negative. And number 4, a cation is an atom that has gained electrons. This is false. When you have a cation, that means it has lost electrons. So that's why it's more positive. So it was neutral, but negative electrons left, and so those protons are still there, and so it ends up with a positive charge. In this whole unit, we're talking about bonding, and in bonding, why do atoms bond? They bond because they become more stable. And besides becoming more stable, they also are lower in energy. So the noble gases, they are stable by themselves, so that's why the noble gases do not bond. Remember, they used to be called the inert gases, meaning that they didn't react with anything. All the other elements, they need to bond with another atom and have either sharing electrons or an exchange of electrons to become more stable. How it bonds determines its properties, and so we're going to be talking about that later on in the unit. All right, a lot of times we say things like, oh, that atom wants to gain an electron, or that atom wants to lose an electron. That is not what's happening. Instead, we should say just a little tiny bit of energy given to sodium and it can lose electrons. We can also say that if you give a lot of energy to fluorine, then it can lose electrons also. But as far as between which element will lose or gain electrons, having a low amount of energy to lose an electron, that is more likely to happen than it would for fluorine. So fluorine, chances are this is not going to happen because it just takes too much energy to do that. And so we find that metals, it takes a little bit of energy to lose an electron, but nonmetals, it's so large that that's just not going to happen. All right, first ionization energy. So ionization means we're making an ion. And remember, an ion is an atom with a charge. So that's what ionization energy means. And if I look at first ionization energy, that means it's the energy required to remove 1 electron, the most loosely held electron from the element. And most of the time this happens with metals. So metals have a very low amount of ionization energy. Nonmetals have a high amount of ionization energy. So again, low over here with metals and high over here with our nonmetals. So this is the trend. As I go towards those nonmetals, this is an increasing in the ionization energy, and as I go up, there's an increasing in ionization energy. The higher the ionization energy, the higher the attraction between the electron and the nucleus. And if you recall, we have talked about the size of atoms, and the smallest atom that we have is helium. So very, very small atoms here, and the largest atom that we have is francium. And so if you notice, the trend of smallness follows the first ionization energy. And that's because the smaller the atom, then the closer all the electrons in that small atom are to the nucleus. And so then to go and rip it apart from the nucleus, it's going to take more energy. And that's what we're looking at with ionization energy. So again, nonmetals have very high ionization energy, or that is the energy to remove an electron, and metals have a very low ionization energy. One more thing to talk about. When we look at a periodic table, we find that down here at the bottom, with the large atoms that we find that they have a low ionization energy. You would still have the nonmetals be higher in this area than the metals over in here. But in the family, the large atoms at the bottom would be lower ionization energy. And this has to do with the size of the atom. So when you look at an atom, nucleus in the middle, and they have all these energy levels. And as the atom gets larger and larger, the electrons on the valence electrons, the very outer electrons, they are loosely held. And we find that the electrons that are inner electrons are going to shield the nucleus's pull of those outer electrons. So this is called shielding effect. So again, it's these core electrons that are going to shield the pull of the nucleus on those valence electrons. And so this shielding effect, this causes it to be easier to pull off that last electron. So again, shielding effect means that, all right, so look at this and see if you can answer the questions 1, 2, 3. Go ahead and stop the video and see if you can figure it out. Be careful what I ask you. Sometimes I ask you higher. Sometimes I ask you lower. In this case, I'm asking lower. So make sure you understand that trend. So stop the tape and answer it. Okay, we're back. So looking at the periodic table, we find that the lower first ionization energies are going to be closer to where the metals are. So more on the left-hand side of the periodic table or on the bottom of the periodic table. So we have calcium and magnesium, and calcium is lower than magnesium, so this would have the lower first ionization energy. Looking at number 2, we have iron and zinc. We have iron is closer to the left-hand side or where the low ionization energy is. So that is the low one. And then on number 3, we have neon and fluorine. So they're next to each other on that second row. They're both nonmetals, but we find that neon is a noble gas. So it should have the highest ionization energy of that row. And here we want the lower. So it's going to be fluorine.